Welcome. Today we're going to learn about the second derivative test. So what is this second derivative test? Well, basically it's another way to find extrema. We've already learned the first derivative test, so this is another way to do that. In other words, this is a way that we can find where our relative maximums and relative minimums are along our function. Okay, so how do we do this? Well, in step one, we first of all start with a function where the first derivative at c being our critical value, is equal to 0. So we will need to set our first derivative of our function equal to 0 first and solve to obtain c, which is, as I said earlier, a critical number. Okay, so we do that first. In step two, the second derivative of the function must exist on an open interval containing our critical number. So obviously if we can't take the second derivative of our function or it does not exist, then we cannot apply this particular test. All right, in step three, the next thing we're going to do is we're going to take the second derivative of our function at c. In other words, we calculate the second derivative, then we're going to take any c values, any critical numbers, and we're going to plug them into that second derivative. And then whatever result we get from that will help us conclude whether we do have a maximum or a minimum at that at the value c f of c. Okay, so let's see the different scenarios. So the one scenario is what we have in A. In this case, the second derivative at c happens to be positive or greater than 0. So what does that tell us? Well, it tells us our function will be concave up and at c, and we will have a relative minimum at c f of c. In B, that's our next scenario. In this case, the second derivative at c is negative. So now our function is concave down at c and has a relative maximum at c f of c. And then in step C, that is our third scenario, here the second derivative at c turns out to be 0. So if that happens, our test fails, and that means we're no longer able to use the second derivative test to draw any conclusions. However, we can then use the first derivative test and figure out what's going on using that test. So let's try an example. So if you look at 1, here's our function. At 2, what we do is we take the first derivative of our function, we set it equal to 0. In 3, we just factor those results, and in 4, we solve, and that gives us our critical numbers, and we wind up with x equal to 0 and 2. Those are our c's. Okay? Now, step 5. We need to calculate our second derivative, and that's all I did. I did factor just to make it a little bit easier when we plug c back into that, but basically I've just taken a second derivative. Okay, so we have two critical numbers here. We have 0 and we have 2. So we have to plug those values back into our second derivative to draw our conclusions. So if you look at column 9, we have 0, and we plug that into the second derivative, and in that scenario, row 7, column 9, we wind up with 0. And as we said earlier, that tells us the test fails. So we cannot use this test to come to any conclusions here. We have to go back and use the first derivative test. Now, I do have a separate video that shows how to do that, that goes through same process but uses the first derivative test. So we're not going to draw conclusions based on this test for the value c, for when c is 0. Okay, but we can try the critical value too and see if we can get any success there. So if you go to column 10, we take that critical value 2, plug that into the second derivative, and in this case we get a value, we get negative 80, which is obviously less than 0, it's a negative number. So the conclusion that we can draw is that our function is concave down at 2, and we have a relative maximum at 2 f of 2, or 216 in this particular case. So let's look at the graph. We had two critical numbers, 0 and 2. So if you go to 0, 0, that point, you'll see just looking at our function, because this is a graph of our function, that we have a minimum at 0, 0. However, this particular test did not give us that conclusion. You would have had to done the first derivative test to come up with that. And as I said, I showed all that on a separate video. However, we were able to get some success with the critical value too. We concluded that using the second derivative test that we have a relative maximum at 216, and you can see it graphically here. And that is the second derivative test. Now go practice, practice, and practice some more.